Welcome everyone for the session with ACX about Entra PA proof of concept for the one of the complex customer in United States. We are talking about the new concept, how to modernize the VPN services for workers and gaining to control to as well to the on-prem services. I will hand over to Risto Niva, who will introduce the ACX team, and Mikko and Brandon will take over the technical part of the session. Please enjoy.
Thanks, Juha. Hi and good morning all. On behalf of our ACX team, I want to warmly welcome all of you to this morning webinar. My name is Risto Niva and I'm running our business here in Europe and in Finland also. In this morning webinar, we want to introduce to you world's first Entra Private Access proof of concept. Our experts are this morning session Mr. Mikko Peltola, our company COO, who is located in Dallas, Texas, and Brandon Crawford, our company CTO, who is located in Vancouver area, Canada. But now, Mikko, it is your turn. Please continue.
Thank you very much, Risto. Let's take a brief look at what ACX does before we dive into the Entra Private Access content. So we are a team of product makers. Our background varies from design to product management to engineering. And we have all built successful products in the past, and now we help companies build great offering, great products, especially in two areas on approachable AI and secure cloud. So approachable AI is our way of bringing AI into products. AI shouldn't be the main element of the products, but it should be used to make even better products. What we found out is much of the content about AI that is available is highly technical or hard to digest. And we have started looking right on the very early days on into the AI content and explaining that in very simple terms. We created a ton of webinars and then helping companies build their AI story, their offering. The other stronghold for us is secure cloud. So we have helped many companies move from private cloud to public cloud on AWS and Azure. We especially focus on the zero trust networking. And today's webinar is actually very much spot on in this domain. There are a few things that we want to go through today. So firstly, we're going to introduce you the proof of concept work that we have done. Secondly, we're going to highlight some of the aspects in our collaboration between ACX, our company, and Microsoft. And then we're going to recap the results and insights of the project towards the end. So let's first look a little bit into this collaboration. So this project, this proof of concept work started early 2024, and it was quite a unique situation. This Entra Private Access was not in a GA. It was pre-GA product. So we created a partnership between Microsoft, ourselves, and our client, and started looking at how could we use the Entra Private Access in the client's setup. The client is a large one. They have tens of thousands of endpoints, and that of course brought some complexity into the equation. And as mentioned, this was very early days for the product, so there were only 4 companies worldwide that had access to this pre-GA product. And only one of these companies, our client, brought a consultancy with them, and the consultancy was ACX. So we were in a very prestigious position that we got access to the Entra GA very early on. We were the first company looking at it and we're working together with Microsoft and our client to make this happen. So what was the gist of the project. It was securing the Windows 365 VMs with Entra PA. So the challenge our client had is that they wanted to secure these VMs from unauthorized access to their critical internal network resources. Our client considered various solutions for that, one of them being Microsoft ExpressRoute. That didn't meet their security goals for isolating the VMs. So they decided to go with the Entra PA and the tunneling approach. And in this way, only registered and authorized applications get the access. Brandon will cover this a little bit later in the presentation in more detail. As expected, there were challenges because this was a pre-GA product, and that's one of the reasons we were involved there. So we set up a daily collaboration with client and Microsoft. We had like weekly calls directly with the Microsoft R&D team, where we talked with them, highlighted what we had learned and what changes would be needed in the product. The objectives were set as the Entra PA should be able to connect the Windows 365 VMs to multiple internal applications. And with those had like varying network protocols and there were very strict latency requirements. And then making sure that the Entra PA offering meets all the security requirements. We're talking about an advanced client. We can't reveal the name of the client, but as mentioned, they were sizable, like tens of thousands of endpoints, very strict security and privacy requirements. So they want to see that there is per application access control, and they wanted to follow zero trust network access. And then the objective was to build or verify that we can build like a solution, so proof of concept. And of course, this was done in the non-production environment of the client, and there were specific requirements for that. So with these objectives, the steps that we took. First one is the requirements gathering. There were a number of stakeholders in a large organization. The responsibilities are split into different organizational units, and they all set different requirements. And also we talked to different end users to understand that all of their requirements will be met. Then we were prototyping this solution, so like giving feedback to Microsoft what is needed, and then like setting up the customer-specific setup so that we can build a prototype that meets all these requirements functionally and usability included. Once that was done and we implemented it, there was a lot of testing to be done. So we did check with the end users and against the requirements from different functional units. And the outcome was deployment readiness. So in this presentation, we're only going to talk about the proof of concept states. So it ends into the deployment readiness, making sure that it's ready to roll out, meet all the requirements, and available at scale. So now I will hand over to Brandon, and we'll look a little bit more in detail on the technical side of the presentation. So Brandon, over to you.
Thanks, Mikko. So yeah, I'm going to take you guys through the technical implementation of this POC. And I think that the best place to start that is to understand why the client was doing this POC and what they hope to gain from it. So as Mikko sort of touched on, our first step was to sit down with the client and really understand their requirements and their goals around this POC. What we learned is that they were trying to connect a set of Windows 365 desktop machines they had hosted in the cloud to a set of privately hosted applications that they had hosted in a private data center. So they were looking to connect from these cloud machines to these privately hosted applications. They were looking to connect in a way that wasn't using a VPN. The reason for this is that if you're familiar with VPNs, when you perform, VPN connectivity from a desktop machine to privately hosted network, that puts the machine on the network. So, you have your desktop machine, you're connecting it to your privately hosted network, and once the VPN is in place, that privately hosted that machine becomes part of that privately hosted network. It can access all of the network resources that are available on that network, and vice versa. The client had concerns around what would happen if one of these desktop machines were to become compromised. So in the case of one of the machines becoming compromised, they were concerned the machine would have unfettered access to the network and unfettered access to all the applications on the network. They wanted to prevent this. So they were looking to move their network from this sort of VPN-based approach to what's called a zero trust network. In a zero trust network, what we do is we put an authorization barrier in between our machines. So we prevent machines from physically connecting to other machines or applications on the network they're not authorized to connect to. We might think about this, for example, like if you were trying to browse to, say, a privately hosted web application. You might browse to that web page, be presented with an authorization screen in which you'd enter your username and password, log into the application. In a zero trust network, if you are not authorized to use that application, your computer will physically not be able to connect to it. So an unauthorized user would never be able to even get to that authorization screen. The client was looking to put something like this in place for connecting their desktop machines to these privately hosted applications. And not only were they looking to put something like this in place, but they wanted to put something like this in place that would ensure that all the communications between their desktop machines and these privately hosted applications were encrypted. So I wanted to make sure that, all the request information, all the response information would be encrypted, what was going across the cloud and being sent into their private data center. Finally, the customer was looking to move their network towards a more segmented deployment. Network segmentation is another typically standard part of building a zero trust network. And what it means is that what you do is you take your privately hosted applications and you separate them onto separate networks. And the reason you do this is so that if your network does become compromised, if an attacker gains access to your network, they're only able to access the small subset of applications deployed on one network segment, rather than being able to access all applications deployed across your entire network. So the client was moving forward with this sort of zero trust networking approach, and they had taken a survey of the landscape of tools available, and they decided that one of the tools they wanted to test with was Entra Private Access. In order to test the tool, the client decided to go ahead with a POC, and really with the POC, the client had 4 goals. The first goal was just to understand whether Entra Private Access would be able to address the needs of this connectivity, whether Entra Private Access would allow them to connect these desktop machines to these privately hosted applications in, a secure and authorized manner. Second thing the client was trying to achieve was to understand what the overhead of putting Entra Private Access in its authorization piece in between these desktop machines and these private applications would cost. So they wanted to the client had several applications that were latency sensitive. They wanted to make sure that when they use those applications, the overhead imposed by this additional authorization hop wouldn't cause issues with these low latency applications. Third, they wanted to understand how reliable the Entra Private Access connectivity would be. The client had been burned in the past by outages in their data store, outages in their network, outages in Azure. And they wanted to make sure that, if there were outages, if things started to fail, this connectivity would continue to persist. Especially in the case with their data store, they had concerns that if things started to fail, they wouldn't be able to connect into, their privately hosted data center to recover machines. So we wanted to make sure that Entra Private Access was capable of routing around such failures. Finally, the client wanted to understand what would be involved in a full-scale rollout. So what we're going to see in a moment here is that the POC consisted of a handful of desktop machines and 2 privately hosted applications, a web application and a database. But as Miko sort of mentioned, this is a very large client, and they were looking to roll Entra PA out across thousands of machines and thousands of applications. At this scale, it's no longer sensible to, manually deploy machines, manually deploy applications, manually set up authorization. And so the client wanted to understand how possible it would be to automate much of that process to make sure that it was feasible to deploy this across these thousands of machines and thousands of applications.
explains the goals. Let's look at the architecture then. Like, how would this look like?
Yeah, so here's a very high-level block diagram of the client's network and what they were hoping to achieve. This diagram shows the three key pieces of Microsoft Entra: the global secure access clients, which are deployed on the Windows 365 desktop machines; Microsoft Entra's edge services, the authorization piece that lives in the middle; and the Microsoft Entra Private Access connectors, which sit in the data center and are co-located with the private applications you wish to use Entra to connect to. If you're not familiar with how Entra Private Access works, what you do is when you make a request from the Windows 365 desktop machine, when you want to, connect to one of these privately hosted applications, the Global Secure Access client captures that request. It forwards it on to the Microsoft Entra Edge service. In the Microsoft Entra Edge service, authorization is performed. We check to make sure you are allowed to connect to that application. And if you are, the Microsoft Entra Edge service forwards your request on to the Private Access connector. The Private Access connectors then terminate your request by connecting you to the private application you're authorized to connect to. Responses work the same way in reverse. So once you make a request, say you make a request to the database then sends the response information back to the Private Access connector. It's forwarded back to the Edge service, back to the Global Secure Access client, and finally back to the Windows 365 machine that originated the request. So once we had a good understanding of how the client's network worked, the next step was to start spinning up the POC. So the first step in spinning up the POC was to deploy these Global Secure Access clients. The Global Secure Access clients are the piece that lives on the Windows 365 machines, on these desktop machines. It's very easy to set up the Global Secure Access client. So Microsoft provides installers if you're just setting this up on a desktop machine. In this case, because we were setting up virtual machines, what we did is we got a copy of the disk image they were using to spin up these virtual machines, and we installed the Global Secure Access client on that disk image. And then we used that disk image to spin up the machines we were performing testing with. Once we'd set up the desktop machines, the next step was to set up these private access connectors. The private access connectors setup was a little bit more complicated than the desktop machine setup. This was because the customer had concerns about the reliability of the system. And so what we decided to do was set up 4 instances of the connectors rather than deploying just one. And the reason we were deploying 4 instances was to see what would happen if 1 or 2 of these connectors were to fail. So we spun up a cluster of 4 connectors within the client's data center environment. Once we had both these pieces in place, the next step was to set up all of the authorization permissions. So if you're not familiar with how to set up Entra Private Access, all of this setup is available under the Global Secure Access tab in the Microsoft Entra web interface. So we went here to the Microsoft Entra web interface under Global Secure Access. The first thing we did was create an enterprise application. So in Global Secure Access, enterprise applications correspond one-to-one with those privately hosted applications you want to connect to. So we created 2 enterprise applications, one for our web application and one for our database application. Once we created these enterprise applications, the next step was to set up the application segments. So application segments are host names or IP addresses that you assign to these privately hosted applications in Entra so that Entra knows you're trying to connect to one of these applications. For example, for our web application, we assigned it a host name. For example, we assigned it, host name web application 1. And then when you attempt to connect to that host name from the desktop machine, the Global Secure Access client knows you're trying to connect to this privately hosted application, and it should capture that request and forward it through the Entra Private Access pipeline. Once we'd configured the application segments, the next step was to set up our connector groups. So we had spun up those 4 connectors in the data center, and those 4 connectors formed one connector group. And all a connector group is a group of connectors that you assign to an application to tell Microsoft Entra, hey, look, if you want to connect to one of these privately hosted applications, or if you want to connect to a privately hosted application, you need to terminate the connection at one of these connectors. So we can imagine, for example, if you had two separate data centers, data center A, data center B, and those data centers had separate applications on them, you would need two separate connector groups, one connector group for each of the applications on data center A, and a second connector group for handling applications on data center B. In this case, because the client only had one data center, we only needed one connector group. And our connector group was composed of these four connectors to basically say to Entra, look, if you can use any one of these four connectors to terminate the connections, if one of these connectors can't be reached for whatever reason, one of the other three can be used. Once we set up this connector group associated with our applications, the next step was to allow access to our applications from our user groups. So to authorize users and groups to access an application using Entra Private Access, what you do is you use the existing groups or users in Entra. It's worth noting at this point that the customer already made use of Microsoft Entra extensively for managing their users and groups and machines in their network. So there was already existing user groups that we were assigned to, and we took those existing user groups and assigned them to these applications. And then those applications we were then able to connect to using that authorization feature. It's worth noting as well that this client used Microsoft Entra extensively, not only for managing users, but managing machines as well. And in fact, they used it for managing these Windows 365 desktop machines and the logins to them. What this means is that when we were doing things like setting up the global secure access clients on these machines, we didn't have to spend time setting up things like credentials on these machines. It was already automatically all handled by Microsoft Entra. So once we had all the authorization in place, the last step was to set up the conditional access policies. If you're not familiar with conditional access is a system by which Microsoft can control where you are allowed to log into your Microsoft account. So what this means is that if you use Microsoft Entra for managing your organization, you're giving Microsoft accounts from this Entra to your staff. You might, for example, restrict login from these accounts to only hardware owned by the company, or only networks physically located within your business. So we had to make sure the conditional access policies were set up such that login was allowed from these Windows 365 machines. And also login would be allowed from the global secure access clients. So we set up all this authorization. We connected all these pieces together. We spun them all up, and it didn't work. And this isn't terribly surprising when you consider that network diagram. There was a whole lot of other things in place to get connectivity between these three pieces of the system. The first thing we learned was that where we had deployed our connectors actually didn't have internet access. So the connectors were deployed, those were those pieces in the private data center, and they were deployed co-located, so on the same network as the applications we were attempting to connect to. But those applications didn't have internet access, and so the connectors didn't either. So we had to bring all our connectors down and deploy them into DMZ so that they would get internet access. But then when we went to discuss with the team managing the DMZ, they were reluctant to open up the firewalls to allow access to the private access connectors. And the reason was, typically, they don't allow access from internet applications into their data center. They only allow access from the data center out to applications. So as you can sort of see in this architecture, and from what we were discussing earlier, it sort of looks like the global secure access clients are connecting the edge services are connecting to the connectors, and the DMZ team wasn't happy about this edge service to private access connector connection. We discussed at length with Microsoft, and what we learned was that even though this is how data flows through the system, in practice, this isn't how connectivity is established. So the private access connectors actually connect out to the Microsoft Entra Edge service. The reason they do this is on startup, the Entra Private Access connector starts up, it reaches out to the Edge service, and it authorizes itself. It says, hey, look, I'm alive to perform termination. So Microsoft Entra is aware of what private access connectors are available for forwarding connection requests to. Once the private access connector has made this connection out to the Microsoft Entra Edge service, it forms a little pipeline, and all future requests to internal applications go across this pipeline. So there's no additional connection forged for each connection, to the internal applications. All of these communications go across this pipeline that the private access connectors already established. So the DMZ guys were pretty happy about this because this meant that they didn't have to allow connections into their DMZ. But they still had concerns about encryption. So another concern they had, shown in this diagram sort of, is that the global secure access client, is connecting to the Entra Edge service, and it's connecting using an SSL connection. It's connecting over an encrypted connection. And the same is true of the private access connectors. They're making an SSL connection to the Entra Edge services, but it's unclear what's happening within Microsoft's network. And the DMZ guys had concerns that because, the Entra Edge services must be doing authorization, they must also be doing some kind of decryption. And what was happening was that requests and responses would be decrypted within Microsoft's network. So once again, we had a discussion with Microsoft, and Microsoft confirmed for us that under the hood, how the system works is that once the private access connectors have, reached out to the Entra Edge services and established this tunnel, and once the global secure access client has done the same, so on startup, the global secure access client reaches out to the Microsoft Entra Edge services and logs in, authenticates itself, and establishes a tunnel. When you make a request to an internal application, the Entra Edge services take these tunnels and join them together. What this means under the hood is that there is an encrypted pipeline flowing end to end from the global secure access client all the way to the private access connector. Under the hood, everything, all your requests, all your responses go via this encrypted tunnel. So no data is decrypted from the requests and responses on Microsoft's network. All the information about authorization and routing is transmitted atop this tunnel. So this kind of information, obviously, Microsoft Entra Private Access needs to correctly, authorize and route your request. But the actual requests and responses stay fully encrypted within this pipeline. So once we discussed this at length with the DMZ guys, they were happy. They were, confirmed that everything would be encrypted all the time. And they were happy to open up the firewall for us on the data center side. We had similar discussions with the Azure team for getting the firewall open from the global secure access client to the Entra Edge services. And it's worth noting that even though these are both Microsoft products, you do have to manually open the Azure firewall to get Entra Private Access through. I will say one of the nice things about Entra Private Access is that you don't have to open the firewall for every application. So we only had to put one hole in the firewall for the global secure access client to connect out, one hole in the firewall for the private access connectors to connect out, and that was it. We didn't have to put a hole in the firewall, for each app of the privately hosted applications we were running. So once we had all these pieces in place, once we had all this connectivity in place, once again, we went to test the system, and this time everything was working. So we did all the usual validation tests. We validated that from our Windows 365 machines, we were able to connect to the configured applications we were authorized to connect to. We validated, we couldn't connect to other locally, privately hosted applications that were unconfigured. We validated, you could be authorized for one application and not the other. And I mean, perhaps to no one's surprise, Microsoft Entra PA does what it says it's going to do on the box. We were able to establish all this connectivity in an authorized manner. Once we had established that Entra Private Access, could make these connections, the next step was to perform some of the testing that the client was concerned about. So the first thing we did was we did some latency testing. I don't have the exact numbers for you in this presentation, but needless to say, the latency testing went well. The client was happy with the latency. They didn't think that it was going to affect their low latency applications. The other thing the client was concerned about, of course, was the reliability of the system. And so to test the reliability of the system, as I sort of suggested before, what we did is we took our private access connectors and we brought them up and down. We just restarted the VMs, and while restarting the VMs, we tried to connect in from our Windows 365 desktop machines to see what would happen. What we found was that Entra Private Access was very good at routing around these failures, even reducing to a single connector. You didn't really notice the impact on the desktop machines. As I noted before, the client also had concerns around the reliability of the overall network, what would happen in case of an Azure outage or something like that. Once again, we spent some time discussing with Microsoft, and what we learned was that the Entra Private Access edge services are globally deployed. So when you connect to Entra Private Access, you're typically connecting to the closest globally deployed instance of the Entra Edge service. You might, for example, be connecting to something like US West 2. So say, you're connecting to that, there's some kind of network failure, Entra Private Access will naturally, by default, route you to the next closest globally deployed Entra Private Access Edge service. So if there is some kind of network outage or some kind of Azure outage, Entra PA is designed to seamlessly route around those kind of outages. So we were able to show the client all these things, and needless to say, they were quite happy. We were able to illustrate to them these 4 goals. A couple takeaways from setting up this POC. I think my personal biggest takeaway was that Entra Private Access touches a lot of things in the network. So one of the things we saw was that, there's all these different pieces of the deployment, different pieces of the network that we were touching. We were touching these desktop machines, cloud things, Active Directory things, Microsoft Entra, firewall, the DMZ, these privately hosted applications. And at a client this size, all of these different pieces were owned by different teams within the organization. And even in smaller organizations, what you might find, is applications and the network and the hardware, all these things are owned by different teams. It's not particularly uncommon. So, because all these things were owned by different teams, a major challenge of the project was coordinating between all these teams to put in this sort of end-to-end connectivity between all these pieces. What we found really helped, and what I recommend you do if you're looking to deploy Entra Private Access, is to have a very good understanding of the current state of the network and a very good understanding of what you want the network to look like once Entra Private Access is in place. So we spent a lot of time discussing with the client, how their network looked. We spent a lot of time putting together some very detailed network diagrams. And by doing this, every time we needed help or assistance from one of the teams within the client's organization, we were able to go to them and say, hey, look, here is this very detailed diagram of the network. Here's what we were trying to accomplish. And here is the piece, you own or we need help with. Can you help us out? And by having these very detailed diagrams in place, we were able to easily coordinate connectivity between all these teams. We're easily able to show people, this is what we were trying to do. This is the overall goal. The other thing that we learned was that once you've started deploying connectors and started deploying clients, deploying more of these connectors and more of these clients is quite straightforward. So, for example, adding more desktop machines to Entra Private Access was just as straightforward as spinning up more disk images, or adding more connectors was just as straightforward as adding more connectors to this 4-machine cluster and setting them up within Entra Private Access itself. The other thing we investigated for the client was how they might go about automatically onboarding all this authorization and all these applications. And what we learned from Microsoft was that Microsoft provides a series of APIs that you can use for onboarding your applications automatically. So while we didn't do this in the client's environment, we were able to take these APIs and demonstrate to the client as part of the POC that yes, you could, use these APIs to automatically onboard applications, automatically onboard authorization pieces. So it was feasible for them to deploy Entra Private Access across, thousands of machines and thousands of applications, which was their goal with the POC, was understanding what would be involved in that sort of a deployment. So yeah, I think this concludes the technical implementation of the POC, and I will turn you all back over to Mikko, and he can discuss the results.
Thank you, Brendan. So the results of the Entra PA project, the client got what they wanted, so a proof of concept that connects the Windows 365 clients with the internal applications in a secure way. The solution consisted of 4 connectors deployed in Azure, a GSA client application on the Windows 365 desktops, and a set of test applications. And as we discussed in the beginning, it is very important that all the various stakeholders across the tech teams, across the security teams, as well as the various end users were happy with the product. And so the client's IT team and security auditors did validate successfully that they were happy with this, and we met all the requirements and expectations of the various client teams. Last but not least, we provided a lot of insights to Microsoft. So we had a very complex, very demanding setup, a pre-GA product, and we could bring insights like how customers would use the product, and that this results into some changes in the actual offering. Now, we don't expect your project to be this complex. The product is now mature in GA, and not everybody's organization is as complex. But we had been through one of the most complex setups in the early days, so we have good capability of anticipating the problems ahead and solving them in an efficient manner. So to help you, we have put together different proof of concept packages. Here is one of them, where we include the following steps. So we start with the requirement gathering. As Brennan explained, it was very helpful to come up and understand the different requirements so that we could always go back to the root and see like what are we trying to achieve here. This included the identity requirements, high-level design, and connectivity. Also, the existing identity management integration had to be explored there, or has to be explored there. Then we identify the applications for the proof of concept. We create the initial connectivity diagrams, high-level network diagrams, and architecture diagrams. And if you again remember how Brandon explained, like in our previous POC, we had to go to different teams, and the better we can articulate what we want, what we need, and why we need it, the more likely we're going to get the results that we want and move the project forward in a swift manner. Then we deploy the Azure resources in your staging environment. We establish the end-to-end connectivity in the staging environment, and then do the performance and control plane testing to ensure the security and performance are validated. So this is one possible setup, but of course your situation, your needs may be different, so we can customize this proof of concept based on your individual needs. Other ways that we can help you, maybe you are not ready to jump into a proof of concept yet. Maybe this is something new for you and you want to understand a little bit deeper. So we have put together a lot of material on this topic, as well as on the approachable AI and secure cloud in general. So if you go to our website, you can leave your contact details there, and we'd be happy to continue the discussion with you. The other resources available there, we have case studies. So for example, one of the late ones is pretty much the same content as in this webinar, if you prefer written format. On the blog section, we have, for example, written a good description about the Microsoft Global Secure Access, the super concept around the private access, how that concept overall differs from the traditional VPN. What are the shortfalls of the traditional VPN approach, and how this zero trust network approach put together by Microsoft is superior. So if you want to understand this on a very layman's term, maybe there's somebody in your organization who would like to get an understanding of this but doesn't want to go too technical, this is a good example of a resource that we put together. And you can subscribe to our newsletter where we highlight the latest and greatest available from us. So thank you very much on behalf of the whole ACX team and on behalf of Microsoft. We hope that this was informative and useful for you. Have a good day.